The following video is on sum, difference, and double angle identities. So we spent a lot of time in the first couple days of this unit learning about trig identities such as Pythagorean identities and reciprocal identities and other things like that that are a little bit um, straightforward. These identities, you have to know them, but you don't really have to know where they come from. There is a video that's posted that's optional that you can watch that tells you where they come from, but it's a little bit of a a higher level proof as to where they come from. I want to make sure that you get a chance to see it if you want, but you basically just have to know these identities. The first is what happens if we add or subtract. Well, I'll just show you all the identities first, and then we'll kind of just talk about them. So sine of a plus b or sine of a minus b, that's what happens if we add or subtract two angles. Remember that on the inside of a sine or a cosine or a tangent, we're dealing with angles. So what if we have angles that we want to add or subtract? And a primary way that we might be able to see this would be in something like the sine of 15 degrees. Now, we don't know what the sine of 15 degrees is, but we do know that 15 degrees is 45 degrees minus 30 degrees. And so this would be a really optimal way to do that because since we know the sine and cosine of 45 and 30, then we can actually figure out the sine of 15 degrees as a result of that. So that's just one example of where we would use these things. So these formulas are over here. You can look at them. I'll explain each of them a little bit more briefly or a little bit in more detail and give you a mnemonic to help you out. So notice that the sine of a plus b is sine a cosine b plus sine b cosine a. And when you have a minus sign, it's the same except there's a minus sign in the middle. So the mnemonic I use to help myself remember where everything goes is separate signs with the same sign. Separate signs with the same sign. Separate signs with the same sign. Whenever you try and learn a mnemonic, you just kind of have to repeat it over and over again until you remember the phrase or the sentence or whatever. And so what ends up happening here is I keep the sine A and sine B separated. So sine of A and cosine of B are together, and sine of B and cosine of A are together. And then I keep the sign the same. So if it was a positive, it stays positive, negative stays negative. Now the cosine formulas, notice the cosines stay together and the signs stay together. And then the plus turns into a minus and the minus turns into a plus. So the mnemonic I use for that is the cosine coalition changes the sign. The cosine coalition changes the sign. The cosine coalition changes the sign. So notice what happens is coalition is when things band together or they stay united. And so the cosines stay united and then the plus turns into a minus or the minus turns into a plus. So changes the plus or minus sign, changes the operation on the inside. Tangent of a plus b is tangent a plus tangent b over 1 minus tangent a times tangent b. And then all the signs change if it was a minus sign. And I never came up with a good one for this, but my class, my first year here at Waubonsie actually came up with this one. And they seem to really like it, and most people tend to actually remember this one more than the other two. Tan same tan over 1 oppo tan tan. Tan same tan over 1 oppo tan tan. So notice it just basically tells you where the signs are. It's the same sign here, opposite sign here, and same and oppo mean plus or minus depending on what the original sign was. Oh, and I kind of forgot to put a minus sign there. My fault. So we have that going on. And then tan tan just means multiply the two tangents together. So these are the formulas. Now the double angle identities, what if we add the same angle to itself? So we're basically just going to use the formula. Oops. So we're just going to use the formula from up here, and instead of doing a plus b, we're going to do a plus a. So what if we add the same angle to itself? Well, we get sine a cosine a plus sine a cosine a. So the sine of 2a is equal to 2 sine a cosine a, because there are two of them. Now with cosine, remember cosine coalition changes the sign. So we have cosine a minus sine a sine a. And then that ends up equaling cosine squared a minus sine squared a. Now, one of the things about the cosine of 2a is that remember that cosine squared and sine squared have Pythagorean identities, so we can actually write this in three different forms. If I replace the sine squared with 1 minus cosine squared and distribute this, I get 2 cosine squared a minus 1. And if I replace the cosine squared with 1 minus sine squared, I get 1 minus 2 sine squared of a. So there are three different ways you can write the cosine of 2a formula. And then tangent of a plus a, or tangent of 2a, we get 2 tangent of a over 1 minus tangent squared. And that's because tangent times tangent is tangent squared if it's the exact same angle. So these are our double angle identities. If you want my what I actually do, I don't memorize the double angle identities unless I'm in the unit and I've just been working with them for a while. I do have these three mnemonics memorized, and therefore I have these identities, the sum and difference, memorized. And then what I end up doing is I just use the sum and difference identities to come up with the double angle by plugging in the same angle for both A and B. And so then I get all of these formulas over here just because I can use the ones that I memorized up top. But if you want to memorize all of them, be my guest. We're now going to do some example problems. So we're going to find the exact value of sine of 75. You do not have to do this in two different ways, but I'm going to do it in two different ways just to make sure that you know what's going on, and that if you did it a different way than the answer key, you might still get the actual correct answer. So the two ways we're going to do this are 75 can be broken up into 45 plus 30, and 75 can be broken up into 120 minus 45. You actually have a whole bunch more options to do with 75. These are probably the two clearest ways to get 75 from angles that we already know. So it's important that you use 30, 45, and 60-degree reference angles because we already know those. And it may be tempting to do something like 75 is equal to 90 minus 15 because we know the sine and cosine of 90, but we don't know the sine and cosine of 15. So it's important to make sure that we use angles that we actually know. So first, we're going to use 45 plus 30. So we're going to separate sines with the same sign. And so we end up with sine of 45 cosine 30 plus sine of 30 cosine 45. Really, all we're doing is we're just using the sum formula for sine. And then sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 30 is 1/2. Cosine of 45 is root 2 over 2. We multiply things together. We get root 6 over 4 plus root 2 over 4. So that ends up being root 6 plus root 2 over 4. If I did it the other way with 120 minus 45, I have sine of 120 cosine of 45 minus sine of 45 cosine of 120. And then sine of 120 is 1/2. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2, and cosine of 120 is negative root 3 over 2. So I end up with the exact same answer, root 2 plus root 6 over 4, except that the commutative property of addition is used in the numerator. So notice I just used separate sines with the same sign. I knew my cosine and sine of 30 and 45, and I got the right answer. Now, 7 pi over 12 in radians, we can still do the same thing. We just have to make sure that we know how to add fractions. So 7 pi over 12 is equal to 4 pi over 12 plus 3 pi over 12, which is pi thirds plus pi fourths. And then I'll also do it one other way just to make sure that you know that you can do it two different ways. So cosine of pi thirds plus pi fourths, we're going to use the cosine coalition changes the sign. So the cosine coalition, cosine of pi thirds, cosine of pi fourths, they're together, minus the sine of pi thirds, sine of pi fourths. Then I basically just have to know what the cosines and sines of pi thirds and pi fourths are. So 1/2 root 2 over 2, negative root 3 over 2, and root 2 over 2. I end up doing everything like multiplying and stuff, and I get root 2 minus root 6 over 4. If I did this with 3 pi over 4 minus pi over 6, I have cosine of 3 pi over 4, cosine of pi over 6, plus, because remember we're changing the sign, cosine coalition changes the sign, plus sine of 3 pi over 4, sine of pi over 6. I end up getting the exact same answer, but again, the commutative property of addition. So I have negative root 6 plus root 2 over 4. It is really important that your answer makes sense. So sine of 75 needs to be positive, and it's bigger than sine of 60 because as you approach 90 degrees, sines get bigger, they get closer to 1. So this is a relatively big one. Cosine of 7 pi over 12, it's in the second quadrant, so it should be a negative answer. And negative root 6 is bigger than positive root 2. So it's important that you understand that your answer should actually make sense in the context of what we've learned over the last month or so. Now, tangent of 195, we'll do this one on the board without it already pre-written. So I'm going to note that 195 degrees is equal to 150 degrees plus 45 degrees. So tangent of 150 plus 45 is equal to tan same tan over 1 oppo tan tan. So tangent of 150 plus tangent of 45 over 1 minus tangent of 150 tangent of 45. So tan same tan over 1 oppo tan tan. Now the tangent of 150 is in the second quadrant, so it's negative root 3 over 3 plus tangent of 45 is 1. 1 minus tangent of 150 is negative root 3 over 3, and tangent of 45 is 1. So I have negative root 3 over 3 plus 1 divided by 1 plus root 3 over 3. I can't leave my answer like that because it's not rationalized. So I'm going to multiply the top and bottom by 3. Multiplying the top and bottom by 3 is essentially going to multiply by 1. It's a fancy form of 1. It's a FFU. And so that cancels off the 3's in the denominators. So I have negative root 3. And then I distribute the 3 to the 1's. So I get negative root 3 plus 3 over 3 plus root 3. And that's equal to the tangent of 195. Now 195 is in the third quadrant, so this should be a positive answer. Notice that 3 is bigger than negative root 3. And therefore, I mean, I could rewrite this as 3 minus root 3 over 3 plus root 3, and that might help us think about it. But that ends up being a positive answer because the numerator is going to be positive and the denominator is going to be positive. Okay, cosecant of negative 15. Now here's where you complain that Mr. Mead hasn't taught you anything about cosecant. And, well, he kind of has. But first, let's start with negative 15 degrees is equal to 30 minus 45. And now after I notice that, I'm also going to remember that cosecant is the reciprocal of sine. So what that means is that sine is the reciprocal of cosecant. So what I'm going to end up doing is I'm just going to find the sine formula, so separate sines with the same sign, and then I'm going to do the reciprocal of that at the end, and then I'll end up with the cosecant one. So sine of negative 15 degrees is sine of 30 minus 45. So that's separate sines with the same sign. So sine of 30, cosine of 45. Same sign means minus. Cosine of 30, sine of 45. So now sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. And sine of 45 is root 2 over 2. So I end up with root 2 minus root 6 over 4. Root 2 minus root 6 over 4 is the sine. Remember that we're finding the cosecant. So cosecant is the reciprocal of sine. And so I'll just take the reciprocal of this. So cosecant of negative 15 is equal to 4 over root 2 minus root 6. That, unfortunately, is not rationalized. So I'm going to multiply by a FFU, and I'm going to use the conjugate of the denominator. So I'm going to multiply by root 2 plus root 6. So I end up with, that's a time sign. Then I end up with 4 times root 2 plus root 6. And the denominator, when I distribute, root 2 times root 2 is 2. Root 2 times root 6 and negative root 6 times root 2. Those cancel out. That's always why we use a conjugate, is it always ends up canceling out. And then negative root 6 times root 6 is negative 6. So I end up with 4 root 2 plus root 6 over negative 4. And that, I can just cancel off the 4 and negative 4, and that becomes negative 1. So it's negative root 2 plus root 6, which if I wanted to distribute, that is root 2, or negative root 2 minus negative root 6. So that is the cosecant of negative 15 degrees. We'll do one more problem on this video. Let's assume that A and B are in standard position. I'll draw them really quick. Sine of A is 1/2 and cosine is negative. So if sine is 1/2 and cosine is negative, that means we're in the second quadrant. So sine is 1/2. So that looks like a 30, 60, 90 triangle. So sine of A there is angle A. And then angle B, we have tangent is 3/4 and sine is negative. So tangent is positive, sine is negative. That's in the third quadrant. So that's 3/4 for tangent. So that's a 3, 4, 5 triangle. So if I have cosine of A minus B, that's the cosine coalition changes the sign. So cosine of A, cosine of B, plus sine of A, sine of B. So basically what I do is I use the triangles that I just drew right here. And then I end up with just subbing stuff in. So cosine of A is negative root 3 over 2. Cosine of B, I probably should have made all of these negative over here. That would have made it a little bit easier on me. The cosine of B is negative 4/5. The sine of A is 1/2. And the sine of B is negative 3/5. So now I just simplify things. So I have positive 4 root 3 minus 3 over 10, because notice the denominators multiply to 10 in both cases. So I get 4 root 3 minus 3 over 10. Let's do the same thing for sine of A plus B. Separate signs with the same sign. So sine of A cosine of B plus sine of B cosine of A. Let's just start subbing things in. Sine of A is 1/2. Cosine of B is negative 4/5. Sine of B is negative 3/5. And cosine of A is negative root 3 over 2. So I end up with negative 4 plus 3 root 3 over 10. Negative 4 plus 3 root 3 over 10. And that 4 did not look very good, so I'm going to rewrite it. Cosine of 2a. Now, if you're like me, you don't even really remember the formula. So I would just do cosine A minus sine A, which is actually the formula. Cosine squared A minus sine squared A. You can actually use any of the cosine of 2a formulas. You can use 2 cosine squared A minus 1. You can use 1 minus 2 sine squared of A. You can use what I just wrote. Any of those will end up working out. So the cosine of A is negative root 3 over 2. We're going to square that. And then sine of A is 1/2. We're going to square that. So we end up with 3/4 minus 1/4. And that ends up equaling 1/2.